Ladies and gentlemen, welcome. This is chapter 6.3, where we're going to perform function operations and composition. And in this series of lessons here, we are going to do two major things. First of all, we're going to do function operations, which means we are going to add, subtract, multiply, and divide functions. Then we're also going to be able to evaluate what's called the composition of two functions. So let's go ahead and jump right in here. And let's just recall from our memory here that a function is a relation where there is exactly one output for an individual input, and we denote it like this, f of x, where x is my input, right? And f of x equals my output, right? Whatever we've got here, that's my output. So whatever's inside the parentheses is my input, and whatever comes out over here is my input. And if you recall, we had this little picture of a function machine that basically says when I put my input in, I get my output out, right? That's what a function does. When I put a single input in, I get a single output out, okay? So that's what a function is. Now, one thing that we need to recognize is that when we have two functions, we can perform any kind of operation on those two functions to create a third function, right? A function that is defined by the operation of the other two. So let's do some examples here. Let's say we have these three functions, f of x, which is 3x, g of x, which is x plus 3, and h of x, which is 9x to the 6th power. We can add functions by taking f of x plus g of x. And all that means is, since f of x is defined as 3x, we're going to replace the f of x with 3x. And since the g of x is equal to x plus 3, we're going to replace the g of x with x plus 3. And so this new function called p of x is 3x plus x plus 3, which, when we combine like terms, gives us 4x plus 3, right? So we can add functions together. I can say I want to take f of x plus g of x, and we'll add those together. And we use the rules that we've always used for addition, subtraction, multiplication, and division. So let's go ahead and do subtraction now. Again, f of x is 3x, and g of x is x plus 3. So this new function, p of x, is defined as this minus this. And we will remember, of course, from our last chapter, that when we are subtracting, just like with a polynomial, we kind of have to distribute that negative sign. So this is 3x minus x minus 3. So we end up with p of x equal to 2x minus 3. We've got multiplication and division too. Again, we simply replace the 3x times the g of x, which is x plus 3. I'm multiplying these, so I distribute that, and I get 3x squared plus 9x. And so p of x equals 3x squared plus 9x. Again, I'm not introducing any new rules for the operations, but what I am doing is putting it in the context of the function notation, which we've already done. Finally, we have h of x divided by f of x. Here's h of x over here, 9x to the 6th. So this is 9x to the 6th divided by 3x, which, using all of the rules we know about division and exponents, we get 3x to the 5th. That's a funny box. It's a puzzle piece, right? All right. That's everything we got for this first video here. There's some practice questions for you to do back on your Canvas, on your notes. So go ahead and check that out, and then we'll see you in the next lesson.